we're going to talk about the concept of code mutation testing. Some of you might be familiar with the concept. Some might have first time hear about it. So the agenda today is what is mutation testing? How does it work? What problem does it solve for me as a developer? And some best practices. At the end, we'll see a small Node.js project having mutation testing applied in there. Mutation testing, though, as a concept, can apply across all the technologies: Java, .NET, Node.js, JavaScript, everything. We're going to go straight to the end of Node.js. I'm a Node.js developer, so I implement in there. So what is mutation testing? Mutation testing is a technique that is designed to measure the quality and the efficiency of your unit tests. So in other words, it will tell you how good your unit test suite is and how good of a job it's doing to identify what problems or your unit test detect in your code. Or because just because you have unit tests doesn't mean necessarily that you are covering those codes correctly or doing like the best part. You can have code coverage. It doesn't mean you could have a good unit test suite. And mutation testing considers the score of your unit test, how good of tests are. And so how does it work? First of all, the best news is there is no new code required for you to write. Different from functional testing, integration testing, unit test, you need to write actual code and spend a lot of time to write that code in order to get the benefits of that. Mutation testing, there is no code required. It's more like you configure your project to implement one of these. In our case, Node.js uses Striker.js framework, and the framework itself will do all the heavy lifting and all the work for us. And the way it does that is there's something called mutant. A mutant is a slightly different version of your code, and so the framework will change your code in a way that we're gonna try to break it, and then you're gonna see what's gonna happen. So, for example, you have a small function calculate sum of two numbers. It will take an input A and B, and then it will return A plus B. So mutant will say, okay, I see this sign saying return A plus B. Then we try to create a mutant by saying return A minus B, A divided by B, A. So different ways to see what's gonna happen. And then it does this for every single line of your code, literally every single line of your code in all possible combinations of mutation to see what's gonna happen. And then when it does that, so it's created a long list of mutants, it runs your existing test suite. And I'll say, okay, I made these changes, but do you have any tests in here that complain about this change? And as you can imagine, if you have a test that complained about the change, that's a good thing. Meaning that I got that change that you tried to do in my code. In this language, you say the mutant was killed from your unit test. If a change was done and no unit test was able to detect that change, that means the mutant survived. Clearly, you have a gap in there. You either didn't write the test at all for that case, or the test that you wrote wasn't doing a very good job in that part. So I kind of talk about this. So after run the test, you detect the problem and see what actions you need to take in there. So what problem does it solve for me as a developer? Like, if it evaluates your test quality, like we said, it's gonna tell you exactly one step back. With the developer used to say, I had code coverage 100%, best case scenario, which rarely you see that. But let's say best case. I'm like, I'm all good to go. Nothing I can do more to make this code better. That's not 100% the case. Mutation testing will tell you, you do have 100% code coverage, but is the quality of your test good enough to be 100% assurance on your code? And what I mean by that is, so let's get, for instance, we have a function, very simple function that says, it's required to say, first time it says, if client ID is not defined or user ID is not defined, throw an error. So we have two parameters checking on the same line. We have one unit test said, call this function without a client ID. The test will fail, will catch the problem, will throw an error, which is expected, and we say you cover that line. So the line coverage shows covered, but you do not have a test case to say, how about if my user ID was missing? So in that case, your code coverage shows 100%, but when mutation testing come and update every line of every possible combination, will catch this case when you won't send a user ID, the mutant will survive, it will be marked as this case survived. And you know, oh, I see, I'm missing a validation for user ID. So this is an example where you have the code coverage 100%, but doesn't mean that your mutation score was 100%. And so it improves your code quality. And the idea is that when you run your mutation testing score, you'll see that some issues sometimes turn out that you identify a problem on your code and you update it based on that result, or you add more unit tests or coverages to make sure that your tests are testing the actual thing. So in a way, your end result, your code overall is a better quality code. This is a big one. How many of you guys have been in a scenario where you say, I have this big part of the project, it's a legacy, it's something that it works fine. I don't want to touch it because it works, but I'm so afraid to refactor it because every time when you refactor something huge, you'll crash or throw some, not crash is the easiest thing, but like will create some bugs where you're not aware of it. And then you always are hesitant on that. Mutation testing will help you be more confident that if I change this code, if I refactor, I won't have any of these problems. And even though you might say, but I have unit tests, again, 100% coverage, I'm more safe. Again, that's not the case because during the refactor, and this is even a newer thing, for example, back to my previous example, if I have a function that says client ID and user ID are required, okay, I have two functions now, two test cases, checking both of those cases where client missing, user ID missing. I'm 100% covered, and also mutation score is 100% at this moment. When I refactor my code, doesn't mean that if I had 20 functions, my previous version of the code, when I refactor, I still have 20 functions, exact same input, same output, same everything. So that's why you refactor. You merge functions together, you split more based on the code reusability, what's the purpose of your refactoring. So you might end up in a case where the same function that was before is these two params now has a third required param, let's say user type, where you pass this user ID, client ID, and user type, and based on that, the function returns admin user or regular user, some different logic. When you run your unit tests now, these two client and user are already testing there. Will test will say all good, but guess what? You don't have a unit test for user type check because that wasn't a thing on your previous version of the code. And you introduce a new case where you're not aware that this came across because during the whole refactor, you might have cases like this, a lot of them, so you'll miss some of them. But when I run my mutation test again, you will see that, my code was mutated with user type missing. It failed, telling me that this case is not covered yet. You add a new unit test, you run your again, and then you go to a point where now I have 100% mutation score with a new code. I'm more confident that there is no bugs created on this version of my refactored code. So it is a really big help. And here in YAML, we implemented it in our team quite some projects, and we've seen this a lot of. I'm a person who I love refactoring. In my work, if I see some code that I don't like, it bothers me until I find the time to do it. And I know that since I implemented mutation testing, it made my life a lot easier in terms of being confident that, hey, this is good. I beg this code, so let's move forward. Some best practices. Just to add a little bit more to that part of refactoring, you can even do it granular. You can say, my project has, 1,000 of lines of code. So, but my refactor is only these 10 files. You can tell your mutation code test, don't check everything because I might have some other place of the code that I'm not refactoring right now that have not 100% scored. Only test these lines I changed or these files I changed. For this one, I want 100% score. Otherwise, I'm not going to tolerate anything. You can do that granular check instead of having your whole project being tested just because you changed the section of your project. And that brings the best practice when I say mutation testing is a bit resource heavy. And what I mean by resource heavy is a small function returns sum of two numbers. It produced 4 mutants, like a plus b, a minus b, divided, multiplied. So 4 mutants for one line of code. Imagine a project where project I'm working on right now, there are like at least 6,000 to 10,000 lines of code across the whole project. So I expect at minimum 20,000 to 30,000 mutants created by that framework. So running for 20,000 mutants, running unit tests to compare if those are valid, it'll take quite some time and quite some resources. So you start prioritizing and saying, I don't want to test every single line of my code. I'm pretty sure maybe 50% or 60% of your code is like core code, core logic, core business logic. Some of them might be some database initializations, could be some constant, could be some pilot. They don't necessarily need to be mutated to be like a test proven. So you can go as granular as you want, saying, I want this file to be in my test. I want this folder or this line of the code. So you can go as granular as you want and you should do that in terms of rather than having the whole project, unless it's a relatively small project. Implement parallelization. A very good feature of mutation testing is that it allows you to run in parallel. So as long as your processing power, so your machine is powerful enough, you can run 20, 50, 100 in parallel. So we'll take the first 100 mutants, you'll mutate those, run the tests for you, and then take the next 100, which makes a lot quicker the whole time running of the test. Set a threshold. It's similar to what we say about code coverage. Like, we know ideal is 100% code coverage, but who can achieve that? It's very hard to get 100% code coverage. So each company come up with a target, or say for Mega Company works 90%, for some company work 95 or 90, or sometimes even from project value. This project might be deal with sales purchase. I want 99% code coverage because it's money involved. Some project could be something less important. You can say 90%. Same thing do with the mutation score as well. As good as to get 100% score, sometimes it's hard to get 100% score. So make a target and say, if my target is 90%, do not allow any new code coming to your project that is less than 90%, which will start, making your project more. And you can start. Some of the project when I first implemented, it was as low as 70% the score. Now I didn't make my target. I'm gonna make this 100%, or as a team we're gonna make this 100% next month. No, make the next 3 months say from 70 to 80%, and the next 3 months from 80 to 90%, because the score will mean it will give you literally a list of every single part of your code where you're missing a test or where you're missing something. So you can say, I'm gonna pick the first, 50, and then process those tests next month, and then so on until you get to the bottom of the score, or to the score where you are happy with. As you imagine, this can become part of your CI/CD pipeline integration. You can put it as part of every deployment you do, every push you do, that you can either be hard or soft the way they use it, meaning you can say, if my new code doesn't have a 90%, which is my target score, fail the pipeline to let it continue, so you don't let the developer push it. Or you can be soft and say, just notify me or send notification that this new code is below your target. So, but I'm gonna let the pipeline continue. You can be but making part of the integration, it helps a lot. So, see it in action. Like I said, I wanna run a small project, kind of see what we talked, what I said, kill a mutant, survive a mutant. How do I go about it? Like, I'm a developer right now, I'm getting a project, starting for the first time. How do I go about it in terms of fixing the score? So, yes, I see the screen. Okay, so this is a very, very basic project. You cannot get any basic in this. So it has just some very simple function: get user, add user, delete user, and another function is format user. And I have a suite of tests. I'm gonna run all the tests to make sure they all pass. You guys can see it, okay? So you see all tests passed. And then, okay, cool. How about coverage? I'm gonna say npm run coverage. And I see, as you can see, I don't know, is it big enough or is it small? You can see the letters?
Oh, there.
Okay, perfect. Okay, so we can see it's 100% code coverage. In normal world, I say, oh, this project, there's nothing to do with this because it can't get any better. Well, I might prove you guys the opposite. So how about right now to say npm run mutation. Let's see the mutation score on this one. It's 65.8%. So you can be like, how can you be 100% code coverage and only 65% mutation score? It will list you exactly, it will tell you, we've killed 27 mutants, but we have 14 that survived. So at least we have 14 cases that on that 3 functions in total that haven't been tested properly. It gives you this good breakdown here what happens, but it has even a nicer interface where in here on this folder report, this is an auto-generated file. So every time you run the report, it generates that file automatically. So nothing that you do special in there. And then you can open that in a browser mode, which it's a very nicer design. So you see this one, it says, I have only one file, user.js, but if you have more files in your project, you can list all of the files one by one, telling for each file how many survived. And if I click on the file, we have in here filters like show me all the ones, or I right now have it only the one that survived, because those are I care. The one that failed, I was like, sure, test got that one. And look for these red dots. This red dot is telling me before you start that this line of code was mutated in 2 ways, and the test failed to catch that way. So I say, okay, let me see how did you update it? Make me curious. And if you see the one in red, it says if ID is not defined, or name, or user type, one of them is not defined, throw an error because I need all 3 to be there. And the code changed to say, if ID and name are not defined, then throw me an error. Which means if one of them is not, code is not gonna care. You say only if both of them are not defined. But that's not what we want as an application, and test didn't got that. I was like, okay, so I right away I know that in my test, I'm not checking properly ID, name, and user type. I'm like, okay, let me go back to my project, and then I go to my unit test and say, what am I missing here? What I'm pretty sure some use case in there. Now, as you can imagine, this is a demo, so I comment out intentionally these two tests that check the ID and the name. But if I bring them back and run the test again, we'll see right away a better score. Ideally, we should see a better score. So from 65, we see 70. Okay. And then I can refresh this and open the new version of this report. And now on the new version, we should not see anymore the cases that we just covered. So when I go back in here, I see this line of code in here doesn't have any more any red dots because nothing survived anymore. And then I keep going down and down and say, okay, I see another function, format students. This function is designed to prove the point in here, but in theory is taking a first name, last name, is taking a date of birth, major, and a score. Based on the date of birth you pass, it's going to calculate what age is this student. And then also based on the score, it's going to pass if he has a passing or failing score. And we see that this first red dot in here is mutated to how? The code says, get the year of the current year minus the birthday year, which try to get the year of the student. And the code is changed to say, get the current year plus the year of the student, which definitely doesn't going to give the year of the age. So, and I'm like, okay, so I might not have any test for age part. So when I go back to my test, I can go and see, okay, I see now that the developer who wrote this, it's only checking that the age is a number and is greater than 0. Well, that's not good enough. But guess what? That line in there made the code coverage to be 100% because the code had to go in there and check, is this a number? Is it greater than 0? Yes, it is. So move on, code coverage 100%. Well, it's not testing exactly what we should have been testing for. It's testing something slightly different. And then I do the math automatically, manually. So I see date of birth is this. Okay, that guy should be 26-year-old. Let me add that 26-year-old and then run the test again. If I run the test again, it will see that it improved to 85%. So, and then you can go this same way of, and as long as you, as far as you need to go, meaning what's your target? Are you trying to go 100% or are you trying to go at 90%? And when you reach your target, you can decide to say, this tests are or not important to me. So, for example, what I have left in here, I have left, okay, it looks like score is not being, status not being properly adjusted or, taken into consideration. I can see first class saying, if score is true, then mean this function in this way will return always passing, and then it never fail. That means I'm not testing, I don't have a test case. From this I can tell I don't have a test case where score should be a failing score, because if I had a test that would test for a failing score, would have failed in here, saying you're passing true always, so I don't allow you that. And when I go back to the code again, similar concept, I see that I'm not even testing, checking it all for the status, so I need to bring that status back. And this is the way you would go about improving your code. I know that these are very elementary level of examples compared with real-world applications, but in real-world applications, actually they happen more. In here, where it's very obvious that, oh, you're missing client ID or this in your test. So, but in a platform where, for example, again, my project where we're on right now, there are literally about 15,000 lines of code unit tests. Being able to tell in there that I'm missing an edge case or I'm missing a test case without testing is very hard to you verbally identify those problems. But this will tell you exactly these are the spots in all these lines of code where you're missing what you need. So this is the idea of mutation testing. I don't know if anyone, since we have probably another 5 minutes, have any questions or
Having questions, think through that.
Yeah, I just told it. That's why I cut short it myself 5 minutes. If they have any questions, but
yeah. So the question was the upper.
Okay.
This one, this one, but
okay.
yeah, all good.
Yep.
All right.
Work.
Indeed.